The next aspect of electron displacement method is resonance. Let's look at what resonance. Resonance effect. Resonance effect. See, before how we move into resonance effect deeply, I would like to introduce or to explain two things. First, what and what. I would like to explain conjugate system and non-conjugate system. So under this resonance effect now, we have let me explain what we call what? Conjugate system. See, if you are talking of conjugate system or conjugate compound is a compound, is an organic compound that alternates double bond with single bond. Conjugate system compound is an organic compound that alternates multiple bond with single bond. Take for instance now, this compound like this, we have carbon, 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 carbon. Yes, here we have double bond, here we have double bond, we have single bond. Look at this compound now. This compound is what? Is a conjugate system compound. Conjugate what? System what? Compound. In what way? This is a double bond, single bond, double bond. You call it what? A conjugate. Conjugate what? Compound. Any compound that alternates carbon double bond with carbon single bond. And another example of conjugate compound, let me give another one. If you have a compound like this too, carbon, 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 like this. If this place is double bond, single bond, double bond, single bond, double bond, we have single bond, we have double bond, like this. This kind of compound is also what? Conjugate compound. Because the double bond and the single bond, they alternate with each other. So any compound that have this kind of what? Of alternation between double bond and single bond are called conjugate system compound. Take this cyclic compound, this benzene. This benzene, this benzene, here we have double bond, single bond, double bond. Abi, double bond, single bond, double bond, single bond, double bond. This benzene is also a what? A conjugate system compound because there is alternation between what? Carbon, between the double bond and a single bond. So after this conjugate system, we also have a compound, what we call what? Isolated system. So in this isolated system is the opposite of what? Of this. In isolated system compound, there is no alternation between double bond and a single bond. Take for instance here, we have carbon, is carbon, 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 carbon. So here, if we have double bond there, and we have another double bond there, see now, look at this compound. Are they alternate? No. So the double here we have double bond, single bond, double bond. No, if it is this kind of what we call it what isolated compound. This is what called what isolated called what compound. So yes, what makes me deviate to the conjugate system and what isolated system is that one of the unique features of resonance effect is conjugate system. Any compound, organic compound that undergo this conjugate system, that compound will undergo resonance effect. That is, the resonance effect take place in what? In the conjugate system compound, not in what? In isolated what? System compound. So, if you ask that is this a compound undergo resonance effect, you can know from what? From the structure. If the compound is conjugate system compound, therefore the compound will what? Will undergo what? The resonance what? Resonance effect. Because the conjugate compound will give a room for this electron to localize. If this electron would shift to this side, and this one will shift to this side. So the shifting of this pi electron in the conjugate system is what we call what? Conjugate effect. Of the shifting of this pi electron in a conjugate system compound, we can call it what? Resonance what? Effect. Are we? So what is the resonance effect now? Resonance effect is the shifting of the pi bond electron in a conjugate system compound. The shifting of pi bond electron in conjugate system compound is called resonance effect. Or the resonance effect or resonance. Resonance is a delocalization of pi bond electron in a conjugate what? System compound. So let me divide resonance. Okay, what is resonance? Is the ability of, let me say what resonance. This is the ability of pi. This is the pi bonds electron or pi bond electron in conjugate or conjugated system in the conjugate gated to what? System to move to what? To move in between, to move what? In between atoms in a molecule. The ability of pi bond electron to move in the conjugate system, to move a pi bond electron in the conjugate system, to move in between the atom in a molecule is what we call what? Resonance. This is the definition for the word resonance. Or we can also say what? The resonance is the resonance is the localization or can be defined into can be what? Can be defined as delocalization of pi bond electron pi what? Bond, electron, the localization of pi bond electron resulting in the migration of the double bond of the double bond within within the within a molecule, within a what? A molecule. That is the definition of what? Of resonance. Let me bring the example of what? Resonance. I mean, let's look at what? This carbonium compound. If you have a compound like this, okay, we have CH2, yes, we have double bond here. Here I put what? Double bond here. CH2 double bond H. Yes, let me attach a CH2 with a vacant orbital here. So this plus here we have here is tell us that what? It tells us that this carbon has a vacant orbi what? Orbi, it has a vacant orbital, orbit, which is what? This electron devi what? Deficient. So in this compound now, the resonance can take place here. Why? There is alternate between, this is a single bond, this is a double bond. And this also a what? A deficient what? Species. As a result of that, I can simply move or shift this pi bond electron towards to this side. So if I shift it to that side, at the end of the day, I'm going to what? To result to resonance what? Structure, which is what? CH2. Instead of having what? Double bond, it will remain what? A single bond. And here we have C what? H. Instead of single bond here we have a double bond. We have what? CH2. And look at this side now. We have positive here before. We have positive here before. The positive here what? Will disappear because it has gained what? Electron to himself. And the positive we have on top here, it will now come to the side. So this is the what? The resonance structure for this propene carbon cation or propene carbonium ion. So this is what resonance structure. Another one again, you can also have resonance structure for carbon what? CO32. Look at this. CO32 what? 2 minus. We can draw the structure for CO32 minus to have it in this form. We have oxygen, 3 oxygen. Then we have carbon here. We have another oxygen. We have another oxygen here. For this what? Carbon. We know that is what? Buffer bond always, two bond always attached to the carbon. But the atomic number of carbon is 8. It need what? 6, it need 2 electrons in the atom shell. So 2 bond attached to it from the covalent bond. So here we have carbon with double bond. These two are single bond. But this minus 2 we have here, this is the minus, this is the minus. So when this want to undergo what? You can see what we have double bond and single bond. Again, don't forget, in this oxygen here, we have 6 lone pair of what? Of electron. Another one share this one. 6 lone pair of what? Of electron for this oxygen with what? With single bond. So this, if this take the resonance for this structure, the pi bond here will move to this oxygen. When the pi bond here moves to what? To this oxygen, automatically this one, the negative sign here, will come to what? To this. So when the negative sign comes to that, we will have what? O will become O minus because of the what? This part that come here. The bond here will become a what? A single. This is the carbon. The bond here will become what? Double with what? With oxygen. So the minus here what? That will be removed here. This here, we still have the minus here. Good. So this one will now have what? The lone what? The lone pair of electron. So this one will also have the lone pair of what? Electron. So this one, is the next thing that we do now is what? The you realize that this come to this side, come to this side. And the next thing that is happen now, this one, negative sign we have here, it will now come to what? To this side. It will come to what? To this side. And this will come to this side. This one will come to what? To this side. Yes, shifting of this to this, this one will come to this. Yeah, when this negative sign shifts to this side, and the what? The pi bond we have here will shift to what? To this side. And the pi bond here will come to where? To this side. As a result of that, we are going to have what? The compound will be in this form, O minus, single bond, carbon. Then we have single bond, single what? Bond, oxygen with minus. This place will be what? Double bond, oxygen. So we are now have what? Onto the lone what? Lone pair of electron. Yes. If you look at it now, this is what? The resonance structure of what? CO3 2 minus. And at the end of the day, these three compounds, these three, they are not the real structure for CO3. The real structure in CO3 can be in what? In hybrid what? Hybrid orbital form, which is what? Is in this form. We have O, single bond carbon, O single bond carbon, O single bond what? Carbon. Like this, if you have it in this form, do you know that is what? You will now put what? The double bond here. Here, double bond is here. It has shifted to this side. It has shifted to this side. So, but here now, they are not double bond. You now put what? A broken line. Okay. Broken what? Line. Then broken what? Line. This tell us that what? The double bond is not in what? It's rotating between the three what? Oxygen atom. Where are we going to put our minus? We can put our minus what? Two here. This is what we call what? The hybrid orbital. This is the real structure of CO32 what? Minus. Let me give you one example of what? Of resonance. The common example of resonance structure that we all familiar with is what? Is benzene. Abi? Yes, now we are all familiar with benzene. Let me say this is benzene. This is common resonance structure that we all familiar with, according to the what? August Kekuli. So this is benzene. We have pi bond, pi bond. You can see that what? All this electron that is moving here, they are what? They are pi bond electron. Shifting of the what? Of the pi bond electron. So in this benzene now, if I decide to what? To take this pi, will come to this side. This one will come to this side. This pi will go to this side. If that is happen in it, We have what? This is what? We have bond here, bond here, we have bond here. Abi? And again, don't forget, this Abi, this one will still later what? Move to this side. This will still later migrate, later will what? Migrate. So the pi electron, they will continue migrating in the what? In the system ring of the what? Of the benzene. Since it's continue to what? To be migrating like that, we are going to have what? The benzene in what? In this form. We now later conclude that is what? This is the real structure of what? Of benzene. This is hybrid structure of benzene. Between these three now, you may ask, which of the three is the real structure of benzene? This is the real structure of benzene. That better for you to draw the benzene, the real structure of benzene, and put what? Ring at the middle, because the pi electron is not stable here, can move to this side. When it is it will also move. It will continue what? Migrating. That's why it's what? If you want to draw your benzene in this form, put the ring as what? Oh, so this is the hybrid structure of what? Of benzene, the way I draw what? This form. So they can ask you how many canonical structure or the resonance structure of CO3 do we have? It's three. How many? I can also call it what? Resonance what? Structure or canonical what? Structure of what? Of CO3. Let me help you to add another what? Example of resonance of benzene. Let me use what? Uh, Phenol ion. Yes. Can ask what is the resonance structure of phenol what? Phenol ion. If you ask to draw the resonance structure of phenol ion, phenol, phenol ion, phenol ion. Notice this phenol ion is when phenol is what is being ionized by releasing what? The what? Hydrogen. If you have your phenol in this form, see it with O minus. We have it, we have it like this. So, and we can also use what? The resonance to determine the what? The stability of organic what? Compound. Talk about it later. So here now, we can have this oxygen come to this side. When oxygen comes to this side, what happens is this pi bond here will also come to what? To this side. So as a result of that, we are going to have what? The phenol structure will be in what? In this form. This place will become negative. Here we have double bond and oxygen. Why? The negative sign we have there come to this to become a double bond. And this double bond here come to this negative here, this one remain here, this one remain here. The next thing that will happen now, this negative sign will come to this side, this pi bond will come out and come what? To this side. So if it continue like that, what are we going to have? We're going to have what? This is double bond. Yes. What do we have here? We have double bond. This one will come to this side, become double bond. This double bond there move to this end, it will become negative. This one remain here. So this negative will come to this side. This pi will shift to what? To this end. As a result of that, we have what? The resonance structure for benzene, it will be one. This come to this side, it will become double bond there. We have double bond there. This one we have negative, we have what? This bond there. Abi? The next thing is what? This double bond will go to the what? Oxygen, and this one will come to this side. So when that happens, we have what? Benzene to be in this form, double bond, triple double bond. We have one with what? With negative. So this is what? The resonance structure for what? For phenol. So in short now, what is the resonance? Resonance is the localization of pi bond what? Electron in conjugate system. So, and you can use the resonance structure to determine the what? The stability of what? Of organic compound. The more the resonance structure, the more the what? The stability of the what? Of the compound. A compound that is have what? One resonance structure, you cannot compare it with what? A compound that have three resonance structure. A compound that have three resonance structure will be more stable than one with what? One resonance what? So what? Structure. And again, I would like to want to explain what are the compounds. The resonance structure, the resonance effect can take place in three kind of what? Of compound. Let me rub this board down, put it down. Let me add what? The three main type of structure that show resonance. The what? Three main types of structure that show resonance. That show what? Resonance structure. What's the first one? The first, any structure that has double or triple bond in conjugation. Any what? Any structure that have double or triple what? Bond in conjugation. Any compound that have double or triple bond in conjugation must undergo what? Let's so what? Let's so now. Let me give one example of that one. Let us look at this compound. We have CH, H, double bond H. We have single bond H. We have, let me put H here, carbon double bond H, H. Look at this compound. Because this compound has what? Double what? Look at how I drop it. Double bond. But look at the double bond of this compound. Are they in conjugate or isolated? You can see that what? They are in what? Isolated. Therefore, it cannot undergo what? Resonance. Abi? It cannot undergo what? Where what? Resonance. Because I've explained the what we call what? Isolated compound and the conjugate compound. This is it here. Any structure that have double or triple bond in conjugation, this compound can undergo what? Resonance. In what way? By shifting this pi to this side. When this pi comes to this side, this pi bond will come to this carbon. As a result of that, we have what? The resonance structure will exist in this form. This one that is loose, it will become positive. We have single bond here. We have what? H here. This bond here will become double bond. We have what? H here. And here we will have single bond. Carbon here still like this. So the compound here, this compound here that is loose, pi bond, become positive. The one that is gay will become negative. So this is what any compound that have double bond, triple bond, double resonance. This is the resonance structure for this. And we can also draw this one in hybrid form. What is the hybrid form for this compound? The hybrid form for this compound can be in this form. See, this H is 2 carbon. Abi now, with CH at the middle, abi, we have double bond here. Yes, we have double what? Double bond here. Here we have 2 double bonds at the middle. No, don't worry. Don't let me put it there. I can put it, but let me put it. No, this. Let me put it. Let me just leave it like that. So this is what? The structure of what? The resonance structure for what? But1 or but1 2 or but1 1 1 3 di what? Diene. This is the resonance structure. The second one is any structure. Any what? Any structure that have double bond or triple bond in what? Conjugate. In conjugate. Conjugate. In a conjugate atom. Conjugate what? Atom having P or B P orbital. Having P what? Orbital. What is the example of such compound? We can have a compound in this form. So what? Carbon H, we have double bond, CH, yeah. Then with chlorine, this chlorine has its own what? Lone pair of electron. Yeah. So when this chlorine now donates or transfer the pi bond, the lone pair of electron here to this side, this fluorine is p what? Is p orbital. This compound have double bond with atom of what? P orbital. This chlorine is p orbital. Shift this to this side, and what else again? The pi bond here will come to this side. So we are going to have what? C what? CH H minus single bond hydrogen. We have double bond to what? Chlorine. And the chlorine here, we have a what? Yes, this will become what? Minus. Here we have positive. And this can also migrate to what? We can have it in this form that we have CH, H, single bond here, H, double bond, and C what? Cl. Don't forget that what? This is negative, this is positive. Have you now? And you can now put what? This is hybrid what? Hybrid orbital. Hybrid orbital or hybrid structure. Okay, hybrid structure. So it's what I want to do for this kind of what? Structure. Any structure that's having what? P orbital. This may be fluorine, maybe bromine, maybe iodine. That atom is attached to hydrocarbon. So they can also undergo what? Resonance. And the last one under this structure is the last one, which lead us to the word the new subtopic is hyperconjugation structure. So any compound that have hyperconjugation structure is also undergo what? Resonance. So that is the what? Our next electron displacement method. This hyperconjugation structure is also subtopic under what? Resonance.